Okay, 4.9, number 5. Yes, I know the sheet says 4. I rearranged it a little bit. It has this setup here. It gives us a picture. Most of the information is in the picture here. But it says the tension in the rope tied to the wall is 25 newtons. What is the mass of the weight? Okay, so we know this tension here is 25. We don't have any information about this. We don't have any information about this. Okay, so first thing, we have to draw our free body diagram. Now, if we're drawing the free body diagram, the ring here is what the forces are being applied to. So we would have a tension here, and then technically a tension here, but we'll just call this FG because we know that is what's pulling down here with this mass. Okay, so free body diagram. Let me give myself enough room. We know there's FG straight down. We also know there's a tension up at this angle here. So we'll draw this. The trickiest part to this one is getting this triangle correct. So if we put our component triangle like this, okay, our 90 degrees is here. The given here is 85 degrees. So what is left here is 5 degrees. Okay, so we have 5 degrees inside the triangle. We'll call this T2. And then we have the same situation over here. Okay, we have T1. Draw our components in. Go like this and that. It says here it's 75 here, so that gives us 15 degrees in there. Alright, so those are all the forces acting there. The tension in the rope tied to the wall, not the ceiling, tied to the wall, is 25 newtons.
I transferred to a tech.
Alright, sorry I had to pause because I was invaded by 7-year-olds. Alright, so T1 was 25 newtons, the one tied to the wall. Alright, 15 degrees, 5 degrees, I'm good there. Alright, so it's asking us what the mass of the weight is. So we want to know the mass inside that FG. Alright, so first step, net force equations. Set it up in the X. T1x minus T2x equals 0. And in the Y, we have T2 acting up. We have this Y component of T1 acting in the same direction as FG, so minus, then minus FG. This is all in equilibrium, so equals 0. Alright. We are looking for mass, which exists inside this here. Okay, so we want to separate FG and then separate M. So I'm going to rewrite this. FG equals, we're moving this over, so this will stay the same. So T2y minus T1y. Alright, definitions here. Mg equals T2, for y it's cosine of 5 degrees, minus T1, and that will be sine, it's the opposite side, 15 degrees. And there we go. So we want to find this M. So before we divide out our G, let's look to see what we know and don't know. Alright, we know T1. We're good there. constant, T2. We don't know T2 yet, so we can't solve this. We have two unknowns, the mass and T2. So we need to find a value for T2 before we can solve this equation for M. Alright, so we jump here, and we can say, and since we need a definition for T2, let's solve right here. So T2x equals T1x. T2x is sine 5 degrees, and that equals T1x, which is cosine. Right, 15 degrees. So to solve for what T2 is, we divide sine 5. Okay, now plug and chug. T1 is 25 newtons. Cosine 15 degrees divided by sine 5 degrees. We get a value of 277 newtons. Alright, so now that we have a value of 277, we have a value for T2. We look back over here, we want to find M. T2 we know, T1 we know, everything else is just numbers. So M equals, I'm going to rewrite the whole thing, okay, so T2, 277 newtons, cosine 5 degrees, minus T1 is 25 newtons, sine 15 degrees, divided by 9.81. So our G here is not negative because we've already dealt with the direction of gravity. Okay, so we just need the magnitude here. Alright, so 277. Alright, we get a mass of 27.5 kilograms. Okay, so there's that one. That one just has a little bit more trig in it. You could easily just solve for that FG value and then solve your FG later. Just divide out little g. If you stick with the actual algebra that's going on, this is the expression you would get.